Hello, everyone. In this lecture, we'll see GAN application continue from the previous episode. We look at fraud detection, but this time using a more advanced type of GAN, one of the adversarial autoencoders. Okay, let's go to the code. Okay, so in the previous episode, lecture 18A, we saw that the plain GAN didn't perform too well. So we want to make an improvement, and here the idea is to use an adversarial autoencoder. And what is that? Um, so let's see. Uh, okay, so here's a research paper on 2016. Ian Goodfellow, the person who invented GAN for his dissertation, basically also came up some other ideas. And basically what it looks like is, um, I guess, here. Let me share this picture here. So unlike the GAN, what we do here is that we basically have an encoder, GAN encoder, and gets a distribution, okay? Gets a distribution that put in the discriminator, but then we try to train it against a particular distribution of fake latent space so that we actually wrangle it to become under certain distribution. So the discriminator has been trained actually um, to have this latent space under some underlying kind of distribution. And in the reconstruction phase, then when we put the encoder, the latent space even will be wrangled into a particular distribution because we kind of forced it to make such distribution. And then have it that latent space to go through the decoder and reconstruct it and do the regularization here. So update the discriminator to distinguish the true prior samples from the generated samples and update the generator to fool the discriminator. Anyway, so this is sort of a little bit more fancier GAN feature that turns out to be more um, more accurate. And I guess how good it is, let me show you uh, this research paper. They had some um, impressive plots, if I remember. Yeah, here. So the adversarial encoder basically can wrangle. So there is a clustering of the variational autoencoder. This is VAE, so it's a little bit overlapping here. The adversarial autoencoder actually does a little bit much better than the separating each kind of different digits here. And you can actually be more aggressive and have it like nicely clustering. And that leads to better discrimination performance. Okay. Anyway, so these are all technical things. If you're interested, you can look at further. But the point is, we'll use a more advanced adversarial autoencoder, which is like GAN, um, but combines the reconstruction-based approach of an autoencoder with the adversarial training dynamics of a GAN. So it's a mixture of autoencoder and GAN, which is more guided to create more efficiently a realistic image. Okay. Um, so we have basically encoder, we have a decoder, and a discriminator. We have three components, not just the generator and the discriminator, isn't it? Okay. So there are a bunch of explanations of what we do, but here we just show how that performs. So pretty much most of the front part looks the same. We take the credit card data and the distribution and prepare the data, and then build an adversarial autoencoder. Basically, we have like an encoder and a decoder and a discriminator. Okay, and then the encoder, decoder, discriminator build that. Okay, and then what we do here in the training loop, um, um, we basically train the adversarial autoencoder. Um, let's see. Oh, this loop here, isn't it? So, so we basically call the reconstruction loss here also, um, along with the what the GAN feature does with the critique and the generator and the critique. I mean the discriminator. Okay. So anyway, so long story short, using this technique, we can get a lot more decent um, kind of loss because we actually care about the reconstruction loss as well. Um, the ROC area on the curve is close to 90%, isn't it? So, and the precision near 80%. So, obviously, it's doing much better. This time, the normal mean is 0.13 and the fraudulent is now 4.18. So, you can see that it clearly separated the normal and fraud transactions here. Okay. So, the fraudulent transactions are lying out here, isn't it? Uh, and the ROC curve looks a lot more reasonable now. Okay. Okay, so, and you can see we filtered 364 fraudulent, correctly filtered, and missed only 128 in this case. And relative to plain autoencoder, so how does it do this time? So the area under curve is 94% here, and the plain autoencoder is only 50, like 6%. So you can see that this time the adversarial autoencoder on advanced GAN model is actually doing a lot better uh, than a plain autoencoder. Okay, so this was showing the fraud detection of an advanced GAN methods, and you can see that why people actually look for not just plain vanilla GAN, but investigate also into more advanced styles of variations of GANs because they tend to perform it for practice much better. Okay, thank you for watching this episode.